In this video, we're going to explore how to use similar triangles to solve problems. Let's put up our learning goals. So by the end of this video, you should be able to show triangles are similar, and you should also be able to use the scale factor to find corresponding side lengths and areas of triangles. Okay, let's jump right into some examples. Okay, so before we get into the examples, let's just recap and write down the definition of what similar figures means as opposed to congruent figures. So we have, let's do congruent figures. So now congruent figures, they have identical shapes and they are the identical size. So same shape, same size. Now similar figures okay, I still have identical shapes, but they're going to be different sizes. Okay, so keep that in mind as we go through this video. All right, let's do an example here. Okay, so I've put up a question here, and this is going to cover Learning Goal 1 and Learning Goal 2 simultaneously. So let's take a look at the question. To determine the width of a river, Naomi finds a willow tree and a maple tree that are directly across from each other on opposite sides of the shore. Using a third tree on the shoreline, Naomi plants 2 stakes, A and B, and measures the distance shown. Find the width of the river. Okay, so let's help out Naomi with this problem here. So we're going to do this in 3 steps. Step 1 is we're going to show how these triangles are similar right now. So am I going to run out of room? I hope not. Okay, so step 1. Okay. We're going to show that triangle ABS is similar to that little symbol there. Oh, it's not showing up for you. Let me get it up for you. There we go. So we're showing that triangle ABS. S is for sumac there. That's just another tree that Naomi found on the shoreline. Okay, is similar, which is that little squiggly line, is similar to triangle WBM. Okay? And when I wrote WBM, I tried to go in the same way that I did with the first triangle, right? Like I did A, B, and then S, and then A is the same as W, so then I went W, B, and M. Okay, so that's important to do. So the way that we show that these triangles are similar is by showing which angles are equivalent to each other. So let's take a look here. I'm going to do angle. Ooh, my whole screen just shifted. There we go. Okay, so I'm going to do angle ABS is equal to angle WBM. Okay, and when we're writing these out, the angle that I'm saying is equal is the middle letter. So angle ABS, which is angle B, is going to be the same as angle WBM, which is B on the corresponding triangle. So that's important to note. And it's really easy to show which angles are similar by just kind of using the triangles that you just referenced to start as your starting point for your first set of angles. So in order to show that these triangles are similar, we actually need two sets of angles that are similar. So let's write another set. And we have, let's see here, let's use angle BSA is equal to, so if I look at angle S, which angle is that going to be equal to in my corresponding triangle? That's going to be equivalent to BMW, not the car, right? S and M. See how we did that there? Okay, so that's step one. Step two, I'm going to do this on a new layer. Step two, we're going to find the scale factor. Okay, I'm not even sure what sentence I was in the middle of, but the Wi-Fi cut out and I had to go reset it. So I'm just going to continue from step two here, which is finding the scale factor. So that means we're going to figure out by what factor is the smaller triangle smaller than the larger triangle, or by what factor is the larger triangle larger than the smaller triangle. I don't know if that made sense, but you'll see it come to life, okay? So here we go, step two. Find the scale factor. So in order to find the scale factor, what I'm going to do, I'm going to take away step one here, and I'm going to move step two upward so we have a little bit more room. Perfect. So what we need to do is pick corresponding sides in each triangle that you have a measurement for. To find the scale factor. Okay. So that's what we're looking for. So if I look at these two triangles here, and I'm trying to find the scale factor, so I'm trying to find K, I'm going to look for two sides in each triangle. So two sides in total, one from triangle, maybe we'll just do this so I can refer to them as triangle 1 and triangle 2. So which side in triangle 1 and which side in triangle 2 both have side lengths and are corresponding to each other. So if I look at triangle 2, I see that I have side length BM, right? I see I have a 24 there. Okay? And then if I look at my triangle 1, my smaller triangle, if I look at the corresponding side there, that would be side B and S. Okay? So K is going to be equal to 24 over 9.3. This is my scale factor. Okay, let's make a note here though. Note. So the numerator, you're probably wondering, how did I choose where to write what? Why didn't I write BS on the top and BM on the bottom? So I'm going to tell you right now, the numerator should be the number from the triangle whose side length you are looking for. So I know that I am looking for this side length here, right? Because it's asking me to find the distance, find the width of the river. So that my numerator is going to be from the same triangle that this side length is in. That's why I chose 24, right? Because what we're trying to do here is scale upward. We're trying to scale upward. We know that this is 8.4, but we're trying to figure out what times 8.4 will give me the side length of this triangle, which happens to be the width of the river. Okay, so we're going to leave this scale factor in the form of a fraction just so that we can have a more accurate calculation in the third step. Okay, so let's put this to the side. Okay, so let's go into step 3. And now we're going to find what is missing. Okay, I wanted to use like a blanket statement because when we do area, it's still step 3, you're still finding what's missing. So we're finding what's missing, right? In this case, what are we looking for? We're looking for the corresponding side length. Which is the width of the river. Okay, I just moved some things around here because I wanted to keep step 2 on the page somehow. I know it's really tiny, but I think it's better than nothing. Okay, so step 3, we're going to find what is missing. So in order to find the missing side length, first of all, what is my missing side length? Well, I see that it's WM. Okay, so what I'm looking for, what's missing, I know it's W. I'm going to write WM because I know that's my missing side length because that's what they're looking for, the width of the river. So whatever you're looking for goes on the top, okay? So what you are looking for, put as your numerator. Okay. Now, what is WM's corresponding side length? Well, if I look at the smaller triangle, I see its corresponding side length. Actually, I can see it right away because there are the 2 arrows on each of the lines, and that means that these lines are parallel. So, I know the corresponding side length is AS. Now, I'm going to set this equal to K in order to find the corresponding side length. The reason I'm able to set it to K is because in step 2, we already found what K is. So now, let's substitute that in and solve. So I have WM over AS. Let's substitute everything in. So AS is 8.4 equals 24 over 9.3. So the reason that we wrote it this way with K on the right side of the equal sign is because we're trying to solve for WM over here, right? And so we want to keep that on the left side of the equal sign just for like organization's sake. Okay, so let's continue. I'm going to continue. Oops. There we go. I'll continue up here. So I might just have to rewrite it. WM divided by 8.4 equals 24 divided by 9.3. Now to isolate side length WM, I'm going to multiply both sides. Some space here. I'm going to multiply both sides so I can cancel out my 8.4. and isolate WM. So WM is going to equal approximately 21.667 meters. Now, when you're writing your final answer for the missing side length, you need to look at the side lengths you've been given already. If you notice over here, let me use pink. This side length is written as 24. This side length, written as 21.667, is not really matching the measurements that are in the triangle already. So what we want to do is actually rewrite it so that it matches the measurements in its corresponding triangle. So what we would actually write this as is 22 meters, right? If you were looking for this missing side length here, and it came up as a decimal with 5 places, well, you would want to write it to correspond to the other measurements in the triangle. So you would round it to 1 decimal place, which is what we're doing here, right? So, and then you can write your therefore statement. Therefore, the width of the river is 22 meters. Okay, let's do another example, but instead of finding a corresponding side length, what we're actually going to do is find the area. Okay, so we're still working on learning goal number 1 and number 2 simultaneously. So we're going to follow the same steps that we did in the first example here. Okay? So do you remember what step 1 was? Step 1 is to show how these triangles are similar. So we can do that. We have space up here. Let's do that up here. Okay. So I'm going to do step 1. And I'm going to say triangle. I'm going to do KRG is similar to triangle NRQ. And now I need to pick my angles that are corresponding here. So I'm going to do angle KRG is equal to angle NRQ. So I'm basically showing that right here, right? Those are the 2 angles that I'm talking about. I'm saying that those are corresponding to each other with this statement. I'm saying that they're equal. Okay? And then I need another set of angles. So I'm going to do angle RKG. So if I'm talking about angle RKG, which angle am I referencing? I'm referencing angle K, right? Maybe I shouldn't do it like that. Maybe I should do it like this so it doesn't look like an equal sign. So I see angle RKG, and I'm going to say it's equal to angle R. Now, which angle is going to be equal to K? That's going to be N. RNQ. So what I'm saying with that is that these 2 specifically here, right? This whole thing can be underlined. That's what I'm saying with this statement here. Okay, hopefully you can see all of that clearly. Okay, let's move to step 2. Do you remember what step 2 is? Step 2 is we need to find the scale factor. So, step 2, I have to find my scale factor, which is K. I'm going to add a second line under these like I did before. So, K equals, do you remember what to look for? I'm looking for two side lengths that are given, one in each triangle, so that I can find my scale factor. Well, I see in my large triangle, I have a side length for side KG, and I see that in the small triangle I have its corresponding side length, which is NQ. So that equals 3.0 over 1.0. So K equals 3, because that's a nice whole number, so we can go ahead and divide it. So now that I've found my scale factor for my sides, in step 3, if you remember, I have to find what's missing. And what's missing here? What are they asking for here in this question? Well, they're asking for the area of the shaded triangle. I'm not sure if I said that at the beginning. My Wi-Fi was giving me trouble again, so my apologies. The whole point of this, I think I said area, is that we're looking for the area of this shaded triangle. Now, in order to find the area of the larger triangle, I'm going to actually first find the area of the smaller triangle, because it's already given me both the measurements that I need. So I can do the area of triangle NQR, which will be equal to 1/2 base times height. That's how we find the area of a triangle. So I'm just going to substitute in the information that it's given me already. My base is 1 kilometer and my height is 1.4 kilometers. So I know that the area of triangle NQR equals 0.7 kilometers squared. Okay? Now, what we're going to do is we're actually going to use a formula, you could say, yeah, that you can use to solve for an unknown area. Okay, so let me write down that formula for you. I'm going to make some space up here. So here is the formula. It is area of the triangle, I'm just going to call it PQR. It's not any triangles that are on the screen right now, okay? So area of triangle PQR is equal to our scale factor squared times the area of triangle ABC. Okay, so let me see if I can draw this for you. So triangle ABC is similar to triangle PQR. That's why we can do this. So I want you to picture that triangle ABC is in this situation, it's the small triangle that we have the area for, right? And what we're looking for in this question is the large triangle, which is PQR, okay? So what we're able to do with this equation is substitute in the information that we've discovered already. We found down here, we found the area of the small triangle. So now that we've found the area of the small triangle, we can find the area of the large triangle by substituting in the area and substituting in our scale factor, which we've also already found in step 2. So what that would look like is, in this situation, you're finding the area of which triangle? We're finding the area of triangle KRG, right? That's the shaded one. Just try to match the color for you. Equals to our K factor squared times the area. What's the area of triangle? We have a small triangle here, right? NQR. So what we can do now is just substitute. So that equals 3 squared times 0.7, which equals 9 times 0.7, which equals 6.3. So the area of triangle KRG is 6.3 kilometers squared. So you're able to use this formula up here once you find your K value, right? And once you find the area, let me draw it directly to the thing. You found your K value and you found the area of one of the triangles, right? The smaller triangle here. That's how we were able to do that. That translated into this down here. So just to close out this video here, I think it'd be really great for you to copy down the formula that's up here. The area of triangle PQR equals our scale value, which is K squared, times the area of triangle ABC. So that when you're working with triangles in the future and it's asking you to find the area of a shaded triangle, you're able to use this.